All right, so today we're going to talk about chemical reactions. And the first place to start is a classification of chemical reactions. So there's some broad categories that chemical reactions are in. So I'm just going to go through the broad classifications that there are, and then a helpful clue to kind of identify like where that reaction is located. So here we have composition and synthesis. And the big clue to that is you're putting things together. And a clue for that would be like an English composition paper. And when you write a composition paper, you're doing research and kind of bringing in a bunch of different themes or ideas, and you're formulating like one product from that. So if you look at this equation here, you have two hydrogens and one oxygen forming water. And the basic setup is you have more than one reactant and it's forming one product. And anytime you have that, that's going to be a composition or a synthesis reaction or a reaction type for that. The opposite of composition or synthesis is decomposition, which is breaking things apart. And so, for instance, anything that is dead or decays or decomposing, you're going to start with one reactant and get multiple products of that. So the general theme is you have one reactant and multiple products to make that work, and so therefore this would be a decomposition reaction. Combustion would be the next one. So in a combustion reaction, you're blowing things up or burning things. You have a hydrocarbon and oxygen that's going to equal carbon dioxide and water. And the hydrocarbon are things with H, C, and O. And then an equation for this would be like CH4 plus 2O2 goes to CO2 and 2H2O, and that's going to be a combustion reaction. For a single replacement reaction, you have one thing that replaces another. It's like dating. You'll have this thing called the metal activity series, which I'll provide for you guys. And then the equation would be that you have this nitrate. And basically the nitrate is currently dating the silver. And then the zinc comes along. And so the nitrate looks at her dating list and she deems zinc as a more attractive individual. So then she kicks silver to the curb, and now she's with zinc. So for instance, in this one, you basically have this girl here is with this guy, Frank, and then Joe comes along, and she's more into Joe than Frank. So she kicks Frank to the curb, and now she's with Joe. So we'll do examples of these. You'll always have access to the metal activity series. You want to memorize it. But essentially, this will help you do these single replacement reactions. Then for the double replacement reactions, everything switches. So the clue would be like dance partners. And you'll have solubility rules for this. So if you look at this equation here, we have AgNO3, we have CaCl2. And then what's going to happen is the silver is now going to be bonded with the chlorine, and the calcium is going to be bonded with nitrate. And so you can see with this diagram here, we have Wilma and Betty. I don't know why George Jetson's in this, but whatever. George Jetson is with Wilma. And so you have Fred with Betty, George Jetson with Wilma. Then what's going to happen is you're going to switch partners. So Fred's with Wilma, and now George Jetson is with Betty. So everything switches partners, and you'll need to know the solubility rules for that. So a type of double replacement reaction is a neutralization reaction. And what happens in a neutralization reaction is you're going to have an acid reacted with a base to get you water and a salt. So you have HCl plus KOH. That's going to get you H2O. And the salt for this one is a broad category that means more than table salt, NaCl. And for this case, it's going to be KCl for this to make that work. In a neutralization reaction, if you have carbonate or hydrogen carbonate, you'll also get, on top of water and a salt, carbon dioxide. And we've done numerous experiments with sodium hydrogen carbonate and vinegar. And you guys have seen how sodium hydrogen carbonate unlocks carbon dioxide to make that happen. When it comes to equations, there are certain abbreviations. We've talked about some of these, but I really wanted to dial in on this. So states of matter are listed here. Solid is always listed with an S, liquids with an L, gases with a G, aqueous is AQ. Then what happens is, what I think where it gets a little confusing, understandably so, is that when something's soluble, it's aqueous, and it's listed AQ. And if something's insoluble, it's listed as solid with an S. So in this diagram here, you have like an Alka-Seltzer tablet that's getting dissolved in water. This would be aqueous. And this we have oil that's in water, and oil is insoluble. And so this would be labeled as S. Now there's a protocol for doing single replacement reactions. And so I want to go through this. We'll go through this together in class to kind of cover this. But basically, the single replacement reaction steps are, you have solubility rules. You want to look at that for the reactants. You want to look at the metal activity series, formulate your products, do the solubility rules for the products, and then balance the equation. If you follow these 5 steps in this order, you will never make mistakes as far as doing single replacement reactions. So let's go and do an example with this. So I have AgNO3 and zinc. And if you look at the reaction types, the only reaction type this can be is a single replacement reaction. You know, this isn't going to be double, it's not combustion, it's not composition, it's not decomp. It has to be a single replacement because we have a metal by itself. We look at the solubility rules for the reactant, and when we do that, what's going to happen is AgNO3 is aqueous via the solubility rules that I'm going to give you, and zinc, because it's a metal by itself, is going to be solid. Then we look at the metal activity series, and zinc is higher in the metal activity series than silver when you look at that. And again, you'll always be given the solubility rules, and you'll always be given the metal activity series. So that'll be something you guys will be provided on any quiz or any test. So we have AgNO3 and we have zinc. The reaction will occur. So what's going to happen is we'll have AgNO3 plus zinc, and then what's going to occur is we know the reaction is going to occur because zinc is listed higher. Then what happens is we form our products. So now, since nitrate wants to be with zinc more, nitrate's going to kick silver to the curb. So silver is going to be by itself. And now zinc is going to be with nitrate. So when we look at the solubility rules, what's going to happen is AgNO3 is aqueous, zinc is a solid. Then we're going to have silver is going to be a solid by itself, and then nitrate is going to be aqueous from the solubility rules. Then I want to look at the solubility rules of that. So we have solid, we have aqueous. Then we balance the equation. The only thing we need to balance this equation is we need to put a 2 in front of the silver nitrate and a 2 in front of silver to balance the 2 nitrates that we get attached to zinc. And then we're good. For double replacement reactions, again, there are certain steps to follow. You want to do solubility rules for the reactants. Again, you'll always be given the solubility rules. You're going to formulate your products. You're going to look at the solubility rules for the products, and you're going to balance. So on this example here, we have AgNO3 reacting with calcium chloride. When I look at the solubility rules, nitrate's going to be aqueous with silver. Calcium is going to be aqueous with chloride, so it's CaCl2, aqueous. Since both are aqueous, the reaction will occur. If one of these were solid, there would be no reaction because it wouldn't break apart. So you got to ensure both of them are aqueous, that a reaction will occur. So next thing we do is we form products. And so I'm going to bring Ag and Cl together. Ag is +1, Cl is -1, so it's AgCl. Calcium is a +2, nitrate is a -1, so the formula for this will be Ca in parentheses NO3 2 for that. Then what's going to occur is I need to form products. When I form products from this, we'll have AgNO3 aqueous plus CaCl2 aqueous. We're going to formulate these products. When I look at the products for that, chlorine is going to be a solid with silver, so it's AgCl solid. And then nitrate with calcium will be aqueous for that. And then we'll balance the equation. 2 AgNO3 plus CaCl2 will give us 2 AgCl plus CaNO3 too. And then this is essentially a double replacement. I have 2 practice problems for you guys to do. So go ahead and pause the video, or rewind, and then try to do these particular problems. The first one here is copper 2 sulfate reacts with aluminum. It is a single replacement reaction, so give that a shot. The second one is lead 2 nitrate reacts with sodium iodide, which is double replacement, so we're going to give that a shot. And then I'll go through that on the next slide. So go ahead and pause and give both of these an opportunity. Okay, let's go and move on. So for the first one, copper 2 sulfate reacts with aluminum. It's a single replacement reaction, CuSO4 plus aluminum. So solubility rules over here. So CuSO4 plus aluminum over here. We have the metal activity series. We formulate the products. So CuSO4 plus aluminum goes to Al2SO43 plus copper. And then the last thing we have to do is do solubility rules. When you look at the solubility rules, SO4 with aluminum is going to be aqueous. Copper is going to be a solid. When we balance that, you have a 3 in front of the CuSO4, a 2 in front of the aluminum, and then a 3 in front of the copper, and you're good. As far as the second one, lead 2 nitrate reacts with sodium iodide. It is a double replacement. The solubility rules for that, lead nitrate will be aqueous. Sodium iodide will be aqueous, so we know that a reaction will occur. Move forward the products and switch places. NaNO3 plus 1 minus 1. Lead's a plus 2, iodine's a minus 1, so it's PbI2 for that. Then what's going to happen, we have the products. When you look at the solubility rules, when you look at the solubility rules, nitrate is going to be soluble with sodium. Lead is insoluble with iodine, so we'll have AQ with this one. We'll have S with this one. And then we balance. When we balance that, you're going to have a 2 in front of the NaI, a 2 in front of the NaNO3, and then that will be balanced. We'll actually do demos of both of these in class at some point, but I wanted you guys to work on these ahead of time. So we'll do demos with the copper 2 sulfate with zinc and lead 2 nitrate with sodium iodide. So that's it. We went over reaction types. We went over how to do this. We're going to spend a lot of time identifying reaction types and formulating products when it comes to single and double replacement reactions. All right. Good job.